Welcome, and I'm glad to be batting cleanup here. And trust me, that's a that's a not apt sports metaphor. Um, so we'll be talking about MP authoring and PowerShell. So, this thing working. So in our agenda, we're going to talk about why we want to use scripting, and of course, why we wouldn't want to use scripting. I'm going to discuss a couple of examples that we'll look at in great detail later. These are real world examples, and we'll be seeing some of them actually run. We'll have a discussion on the languages to use with scripting, and spoiler alert, PowerShell. Then we're going to look at a couple of minimal examples, and these are sort of the smallest practical examples I can give you to show the various parts of scripting for discoveries and monitoring. And they're complete, they're sufficient, they're just not what you'd want to use in production. We'll talk about testing, and others have already touched on this, but we'll touch on it a bit more. And we'll show that off a bit when we talk about the advanced examples. So I have two big examples that we'll talk through. The first one I'll be going through in significant detail. And the second one we'll go through a little faster because a lot of it is boilerplate and you'll have seen it before. Not on this agenda, but I have 4 pages of links that are references to interesting articles that you can find on the web. And then we'll have time for a Q&A. So apparently I'm supposed to mention that you can join on Slack. So let's talk about why we use scripting. It's powerful. Basically, you can do anything with the scripting. You can discover or monitor basically anything. You've got full control over it. The reasons are pretty obvious. When there's things that you can't do with SCOM normally, PowerShell scripting is probably going to let you do them. Reasons not to use scripting. Well, performance. The performance with scripting is not bad, but built-in modules are more performant. They're going to use less CPU, less memory. That's typically going to be on an agent. So it's perhaps not the most important thing in the world, but nobody wants customers complaining that their systems are running slow and monitoring agent is the guy who's using 80% of their CPU and 90% of their memory. PowerShell scripting used to, in earlier versions of the agents, basically each time a script was run, it would fire up an in-memory copy of PowerShell. I don't think it used a separate process, but I can't remember. Fired it up, ran the script, got the results, and closed it down for every script. So if you have a script running every 5 minutes, it's going to do that every 5 minutes. And for each script, it had some issues. And so they worked on that. And the latest version of the agent basically fires up an in-memory copy of PowerShell when the first script is run. And then it just feeds in the scripts, runs them, doesn't close things down. So it's much more performant. Now it's still running a script. It's got to interpret it. It's got to execute all that stuff. It's not bad, but if you can use the built-in module types that are already there, it's going to be better for performance. It's also a bit simpler. All the tools and most users are going to already understand the built-in modules. So I wouldn't rebuild anything where I can use the built-in stuff unless I've got a really good reason to do that. You probably could replace all of the built-in SCOM modules with PowerShell modules if you really worked at it. I can't recommend that. Let me take a quick drink here. So the 2 detailed examples we're going to look into are the following. We had a customer had a requirement to monitor a 5-byte reg binary value from the registry for changes. And I thought this would be fairly easy, so I tried it out and I couldn't get it working with the built-in stuff that I had access to. So I started looking around. I ran some Bing queries, I ran Google queries. And the conclusion I came to is that SCOM just doesn't handle monitoring 5-byte reg binary values. I think what it really does, if it sees a reg binary, it evaluates it as a true or false. So it probably looks at the first byte only, maybe. to see if it's zero or non-zero, and that's a false or a true, respectively. Honestly, couldn't find any documentation that said one way or the other what it does. But I knew that we could do it with PowerShell, and so we put together an example, and we'll be going through that one in great detail. The second example is something that comes up very frequently. Customers are looking for measuring the performance of HTTP requests. Now, they may be looking at this like the example that Harold did in his session. He wanted to monitor the Silect portal by using that to create a management pack that would monitor the Silect portal. And so what it does, it executes an HTTP query, gets the results back, looks at the result, whether it succeeded or not, looks at the performance, how long it took, and measures against that for the monitor. So we've put together a fragment. It uses a PowerShell script, and we'll go through that script in detail, that is used by both a monitor and a rule. The monitor uses it, makes the HTTP request, gets the result back, and uses the result, whether it's successful or failure, or it'll also look at the performance. So if the result was returned in less than a warning threshold, then everything's healthy. If it succeeded, but the time was between the warning threshold and the error threshold, then it brings it into a warning state, does not generate an alert. And if it's greater than the error time, or it didn't work, then it'll generate an alert, a critical alert. The rule uses the same data source, same probe, so it uses cookdown, so those are only executed as often as necessary, collects the performance data, has a view and a folder, etc., to show that information, and we'll go through all of that. And we'll talk about that in a couple of minutes. So languages. The best choice is PowerShell. It's the best choice for monitoring and for working as a scripting language in Windows in general. And it's supported on all currently supported Windows OSs. It's all built in. JavaScript, VBScript, no longer advised. Now, when SCOM was first created, PowerShell was in its infancy. A lot of scripts were written with VBScript and some with JScript. There's probably some still out there, but Microsoft is slowly converting all the MP scripts to use PowerShell. We also get occasionally some customer asking whether they can use Ruby or Python or, God forbid, Perl or something like that for scripting. And while you probably could get that working, I cannot overemphasize, don't do that. You're going to be the only people in the world who know how to do that. You're not going to be able to find any help. You do queries, you're not going to get back anything useful to you. Stick with PowerShell, and as VBScript and JScript fall out of favor even further, you're going to have fewer people with that knowledge, and you're going to have fewer online resources to draw upon. Especially since Microsoft likes to periodically change their blogging platforms and their docs platforms, and they just sort of let the other stuff disappear off the face of the earth. So articles and discussions that would have been useful to you can just disappear. If you're using PowerShell, that's current. So even if an old article disappeared, there's probably people asking about the new stuff, or they'll hunt down the old articles using the Wayback Machine and repost them, that sort of stuff. So stick with PowerShell. It's going to make your life a lot easier. So this is a minimal example of a discovery script. And while it's slightly longer than it absolutely has to be, it's not much. All discoveries are going to take in a minimum of 2 parameters, the source ID and the managed entity ID. In this case, I'm also passing in a computer name parameter, and we'll see where that's used. The line 3, new object, com object, mom script API, and assigns that to $API. That is a line you are going to see in every single script that you're going to use. The mom script API provides a small but very critical set of functions that can be used to interface between your scripts, your PowerShell scripts, and SCOM. An example of that is line 4. where we use the API and we create discovery data. We'll fill that in a couple minutes, but we're going to create it now. There's 3 parameters. The first one is almost always going to be a 0. You probably don't ever need to worry about that. I think a 1 can be used for incremental discovery data. I'm not even sure how you'd use that. So use 0 as a constant basically there. And then you use the source ID and the managed entity ID that were passed into you. The next thing we're going to do, and we can ignore the little 3 element loop there that was just done as an example here. But line 8 is a great example for the next step you're going to do. We're going to use that discovery data object that was created on line 4. We're going to create a new class instance. And we identify that class with this lovely syntax of $MP element name equals the name in quotes there, closing bracket, closing $sign. When this script is actually run by SCOM, it recognizes that construct and actually replaces it with a GUID. And it's the ID of that particular class in SCOM. And every $MP element you see there is going to be replaced with the ID of that particular item. But that you don't have to worry about that. That's done for you. Once we've created that class instance, the next thing we can do is we can assign properties or values to properties here. So in line 9, this class is hosted by Windows Computer. So we need to tie those two together. So in this case, we assign the principal name property of Windows Computer to $computer name, which ties these things together. This class also has one string property here with the imaginative name of property name. And here we just assign it a value of component 1, 2, or 3. Once we've fully populated our class instance, we add that to the discovery data on line 11. And in this example, we're going to do that 3 times. So you can create more than one instance of a class in a discovery. You can also create more than one different class and instances of more than one class. You can also create relationships between those classes and assign them. Now that's a bit beyond the scope of what we have time to look at today, but you should know that it's available. Now, to pass that discovery data back to SCOM, we simply put $discovery data on basically one line of the script, and it just gets returned to SCOM. The technical details on that are, I think it returns it as a COM object. It's converted to XML and it's processed further from there. But you don't need to worry about that. All you need to do is return that discovery data. Now, a monitoring script, this one's a bit longer than the other one. It doesn't have any predefined parameters that need to come in. But in this case, this is an example that I took from an article by Way, and I had to go and find that on the Wayback Machine. So the link is there. It's in the source, and I think we're making all that available to you folks. Basically, it takes a file name and a threshold, and it checks to see if the length of that file, the number of bytes that are allocated for that file, is less than or equal to a certain threshold, and if it is, it's healthy. If it's not, it's an error. So line 3 should look familiar. We have this new COM object of mom.script API. We're assigning it to a variable called $API in this case. And then we create a property bag on line 4. Now, a property bag is how monitoring returns data to SCOM. And a property bag is just a collection of names and values. It really is that simple. But we need to create one so we can fill it in. And then we get into the actual guts of this script. We're going to get that file name. We're going to get the file that corresponds to that by using the get item command. There probably should be some error handling in here, but this is sort of a minimal example. We'll assume it works. We get the length of that file. That's line 10. On line 12, we compare to see if the length is greater than the threshold. If it is, that's an error state, and we're going to fill in the property bag with certain things showing that it's an error. And the first one of those is on line 14, where we assign state a value of error. And we also fill in a description. Now, this can be used in alerts, for instance. We say, the file exceeded the threshold of so many bytes, and I think we return the current size there, etc. That's put in there. Lines 17 through 21 are the successful case, where the length is less than or equal to the threshold. We also set the state to OK in this case. And the description says file did not exceed that threshold, etc. And then, regardless of success or failure, on lines 23 and 24, we put in 2 additional properties that can be useful. We put in the file name because that is something that we may want to report in, so that having that in the property bag can be very convenient. We also could have put in the threshold as a separate item. This example doesn't, but often putting in your input parameters into the bag is really useful because you may need them later on. Adding 1 or 2 extra things to a property bag, even if you don't use them, very inexpensive. But we also put in the length. So that's the length we actually got from that file. And then the last thing we do is simply return the property bag like we did with the discovery data. Now, let's talk about testing. Logging to the event log is really handy. And I use it with both developing and in production. When something's been in production for a long time, you might want to turn down the amount of logging. And that's why you'll often see scripts that have, a debug or a verbose flag that's an overridable parameter, so you can turn it back up when things aren't working. And this can really save your bacon. Logging is done using that mom script API log script event method. And that's a link when you get the slide deck, you'll be able to click on that for the documentation on it. It's fairly straightforward. You may never need to look at it, but I certainly wanted you to have access to that. I strongly, and I can't emphasize this too much, strongly recommend testing your scripts outside of SCOM. It's easier and it's a lot faster. When you're developing scripts and testing scripts outside of SCOM, you're running in PowerShell, you hit F5, it runs, you see the results, you can go make a change. A couple seconds later, you can probably do 2 or 3 runs a minute if you want to. But if you're trying to test them and debug them in SCOM, you've got to add that script into probably a probe action. You're going to update a management pack. You're going to save a copy of it. You're going to deploy it and install it on SCOM. You may need to wait for discoveries to run, but you certainly need to wait for that management pack to be distributed to the agent. Then you're going to need that monitor to run. It could easily take 5 or 10 minutes per change you want to make. And there are cases in SCOM where it doesn't run and produce the output that you find useful, so you may not even know why it failed. Getting it working and testing all your known failure cases outside of SCOM is going to make your life so much easier. The last thing we're going to talk about on this slide is reading the script output. Now, the script output comes out as XML, and that article, How to Analyze a SCOM Property Bag, it also applies to all SCOM output so that you can use it with the discovery data as well. By the monitoring guys is a real wonderful article, and it's one I recommend. And we'll see how that's done. It's straightforward, but there's one trick to it. So let's take a look at our first example. Now, this was a customer who wanted to read a 5-byte reg binary value as a monitor and complain, raise an alert or whatever if that value has changed or it doesn't have the magic value. And didn't seem to be any way to do it other than using a script, but with the script, it's fairly straightforward. Now, what I produced here is a script. While it's just an example, the resultant script is general enough that anybody should be able to use that. If you need to do this sort of thing, read a reg binary value and be able to work with it, this script can be useful to you. And I couldn't figure any way to do it with the built-in stuff. So just a quick example. I've chosen almost at random a setting in the registry editor. So it's internet settings for the cache for a cleanup interval. It's a 4-byte reg binary value. rather than there's a regd word that they could have used for the same sort of thing. In my case, the customer's case, they were looking for 5 bytes, which is really odd. There certainly would be no built-in type for that. But this script doesn't care what the length is so much. But that's the sort of thing we're going to be looking at. So let's look at our script now. If this works, and it did, excellent. Here's our script. Now, there's a bunch of things I want to talk about. Comments. Comments in PowerShell start with a number sign. I strongly recommend you comment your scripts. What it is you're going to do, what's returned. I probably should have commented the parameters that come in here as well. It's useful to put in the author's name and maybe even version it. You're not always going to be the last person to work, or the first person to work on something, so knowing who to complain to when there's a bug is useful. The parameters, we're going to pass in 3 parameters here. The first is a registry path, and that is, where's my registry editor? Where is my registry editor? There it is. That would be this part of that path. SCOM is always going to work off of HKLM, the HK local machine. So all you need is the stuff, software down. The other thing we're going to need is the name of the item, which is cleanup interval. Those will be passed in here. And I have a debug flag. Now, I want the debug flag as a Boolean, so I found that this sort of thing works really well to convert whatever this comes, whatever comes in this $debug parameter here. In this case, it's a string. It'll convert it to a Boolean, so I can use it that way. Now, the observant among you may start to notice that this script really has a strong resemblance to Kevin Holman's scripts. And there's a good reason for that. Kevin put an awful lot of effort into his scripts, and he's got a really good structure there. And if you're going to steal from the best. And I have no reservations on telling you that. The next thing we're going to do is for manual testing, we're going to have defined values that we can test with. These in production would normally be commented out. And then we would use the values that came in on the param line. But we want to just do some local testing, so we're going to uncomment them. So we'll put in, basically inject our own values for those. Next thing we're going to do is assign variables for a script name and an event ID, and those are going to be used when we log events. So we'll come and we'll see how that's done in a couple of seconds here. Now, as I mentioned, logging is really important, and Kevin has a process that he goes through, which is when a script starts, log the start, log errors that come up, log success at the end, and then log a final message, which shows how long it took. And it's really great to have that information. So we're going to get the start time. The who am I is really important. In SCOM, every workflow runs as a certain account. Let's call it that, a certain user. The normal default action account is local system, which may or may not have access to everything you want. So by logging it so you know who it is, you can look at failures and say, oh, there's a good reason this isn't using a run as credential that it should be using, and you can correct it. If you don't know who it was running as, it can be really difficult to figure that sort of stuff out. So we log the who am I, and we log the input parameters. Those can be really useful again for your debugging. Now, like we saw in the minimal example here on line 47, we're going to create a property bag. Now this is our main part. We're going to talk about sort of this first section here in detail, and then we'll sort of gloss over the remainder of it. But I just want to give you a sense of what we do here. The whole part of this is we're going to get an item from the registry. So we pass in the path. We're going to use the registry : to say we're looking in the registry, and we do that path that was passed in. And if there's an error, I only want to silently continue. Don't need any output messages because this is typically running unattended. But if there was an error, it didn't succeed for some reason, so we need to do something about that. So we're going to format up a message saying it's a fatal error, and we're going to put the registry path and item name in there, although item name at that point doesn't matter. And we're going to put the error that was logged in $error in that message. And we're going to log the script, log an event. Now, that first log we did, we pass in the script name and the event ID, and 0 is the severity. So 0 is just a normal message. In this case, we're going to put in 1. That's an error, and we're going to log the message. If we're debugging, we're going to write that same message to the host so we see it immediately. And we're going to use foreground color of red so it really stands out. Now, we can't proceed any further, but we need to return something to SCOM. It's really valuable. So I populate the property bag with the registry path and the item name that came in, a result, which is, in most likely in this case, the path does not exist if you can't read it. But we also populate a message property here, and that's the message, and that includes that error here. So if it's permissions or something like that, it's going to be in that message. And we also return the value. We don't have a value, but it's very beneficial to always return property bags that have a consistent set of properties in them so that you can depend on them. So in this case, I return an empty string, which is the best value I've got. And we're going to turn that property bag to SCOM, and then we're going to exit the script. Now, let's demonstrate that. So I'm going to just show what happens in the case of an error here. And I'm just going to change that to something that does not exist. And I'm going to run that. And I'm going to make this big enough that you can actually see what happened. So in red here, that's the messages that we showed. There's our information about the registry path, the item name, and the error, cannot find, because it does not exist, etc. That information is also logged. So if we do a refresh here, we have our start message here. And you can see that Xcache was logged here. And then we have our error message, and it's the same stuff we already saw on the console. So that's just an example of the sort of thing when debugging, you can quickly change that and run it again, and you'll see that it works. Let's just deal with the rest of the script very quickly. Once we have our key in the registry, we can get the value of the item name. And if the value is null, it means it typically wasn't found. So we're going to produce some more messages and we're going to log them. And again, we're going to return a property bag with the same keys, registry path, item name, result, and value, so that if somebody's looking for those, they're there, even if they don't make much sense. Now, the next thing is rather specific to this case. I want the value to be effectively a byte array, a series of bytes, and I want there to be at least 1 here. So that comment is wrong. This is an example of why you want to use PowerShell. I couldn't remember the syntax for this. So I did a quick query on Bing, and it immediately came up to Stack Overflow. And in about 30 seconds, I had exactly the right type here. I don't know. I'm sure you can do this sort of thing in VBScript. I certainly have no idea how, and I'm not sure that you'd find it nearly as quickly. So again, PowerShell. If it's not a byte array, or we have 0 bytes, then we also have another error here. We're going to log messages. We're going to put together a bag. The one thing I wanted to point out about this is for the value here, we have something. We've got a value here. It's not nothing. It's not what we're looking for, but it's something. So I force it to be a string. And the comment is, it's something. It might be useful to return it. Maybe not. Maybe it is. But it's an opportunity that we can return something. Now, everything's working out so far. So this is the only line that actually does anything significant in this. It takes that value, and for each of the bytes, it converts them. It does a toString using this format. I hate that. if you have something highlighted and you drag it, you move it rather than changing the highlighting. Capital X2 will format this as uppercase hexadecimal characters. And then we have, in our case, 4 little hex strings of 2 bytes each. We're going to join them together into one string. And this is a separator. And this is an empty separator. So we're not going to have a separator between them. And that we assign that to this variable hex string. And then we're going to log that we returned hex string. And if it's debug, we're going to write that same message out here. And then finally, we're going to put together the final property bag. Again, we have our registry path and item name. Our result is completed. Our message is the one we formatted up here, read successfully, value returned, etc. And our value is the hex string value here. And then if we're not debugging, we would simply return the property bag to SCOM and then log a final script event here, which says, how long it took to run. It's completed and it ran in so many seconds. The code here for debugging is the stuff we need for testing. So you can see what's in the property bag, which helps your testing, if you return it this way. Now, that doesn't work in SCOM to return the results to SCOM. This is non-SCOM only. This is what you have to do for SCOM. But this is what you can do to debug it. Now, the trick is it doesn't work in the ISE. If we run this in the ISE again, we get that, and we get no significant output here. We just get that debug message that we said we were going to see. There's our value. But we can run it in normal PowerShell. So we'll just run it here. There's that same message, registry read successfully, value returned is, and we get all this lovely XML here. Now, if you want to understand that, and this is that trick we were talking about, you can load it into, I'm using Notepad++ here. Obviously didn't paste in what I thought I was going to do here. Let's come back here and copy that. Thank you. Paste it in here. Tell it that the language is XML, so it highlights properly, and use the XML tools plugin and do pretty print, and now we have it. So all the data in SCOM is a data item, and the type says what it is. So this is a property bag. It's property bag data technically. A couple other bits of information there. You'll recognize all these things. For each property, we have the registry path, the item name, the result, the message, and the value. And we have this variant type. Variant type 8 is a string. So here's all of our values. It completed successfully. There's our value, and we can look at that. Now, I had already done that before, so that's here, same sort of thing. So the next thing we can do with this script is that we can add it into a management pack. And I'm just going to show you how we do that in MP Studio. I have a completely empty MP that I created here. We look at the summary, there's nothing in it. So I'm just going to go through and do the monitor here. So I'm going to create a new script monitor. I'm going to target Windows operating system for convenience. Normally you would target something a little less broad than that, but it works well for this demonstration. That's that script we were playing with. I'm going to load it up here. Oh, and I got to remember to turn off the debug stuff here, or it isn't going to work. But when MP Studio loaded this in, it found this params line. And so it knows that we have a registry path variable that has to come in, an item name, and a debug variable. And so it adds these 3 script parameters here. So very quickly, I'm going to fill them in. And I'm copying and pasting because if I start typing, we'll be here for a week. Because one thing I've learned over the years, I can't type when someone's watching. Item name, and we'll fill in the debug with just false. Now these are all going to be overridable parameters, so you can change these if you need to. Just coming back to this for a second, our script time is set for 5 minutes. More than enough time. If you saw the the messages here when it actually ran successfully, it took 21 milliseconds. But we don't want to depend on that. But we certainly don't want it to run forever. 5 minutes is way more than enough, but it'll do. Now here we're defining our health states. I'm going to get rid of the middle ones. We only have healthy and critical. Our result, in this case, we were seeing results here is completed. So that's the thing we're interested in. So our result is equal to completed as a string. That's our healthy state. Our unhealthy state is also going to be result does not equal that value as a string. And one thing I like to point out here is you always want your health states to be inclusive. Now, this one is an equals something specific, so this one is the not equals. It's the complement. You want to make sure that there's no case where the values can be returned where neither health state evaluates properly. You always want at least one health state to evaluate correctly. You can guess how I found that out. We don't care about the identification. We don't use a run as here. We would schedule this to run, say, every 15 minutes. We would generate an alert. And we can put in all sorts of information. So we can create, and we know what's in the property bag. We've scanned that script, so we know what's coming in the property bag. We can do some quick substitution in there. We can also put in properties of the target and the host of the target, which in this case is the Windows computer. We can even put in some information about the group if you care. But just for an example here, I could say this. And the reality is I completely screwed the pooch back here. I should not be testing here for result. I should have been testing for value here. And I've messed up. So let's quickly change that because that's what we really wanted here. It won't matter, but I can't proceed without doing this right. Value does not equal that, and this state would be, sorry, way out of my comfort. Let's go forward here. So here we have our So here we have our alert message, which tells us what it is we were looking for and that current value. Thank goodness I saw that. Here we have a summary of all the things we're going to do, and we can go back and change that. But the important thing is here, our healthy state is value equals that. Our unhealthy state is value does not equal that. They're complementary. Finish, and there we have our monitor. And what we've actually created is more than that. So if I look at the summary here, we have our unit monitor, we have a data source, a probe action, we have our string resource, which is the alert message, and the unit monitor type. And I'm going to delete all of that now because I want a clean management pack for our next example here. So let's go back to our here. We're going to look at our second case. So the requirement that's come up a lot of times is people want to be able to look at HTTP traffic to see whether it's successful and see the performance here. So we wanted to create a fragment that would do a couple things. It's going to have a monitor that monitors the success of the HTTP read and the thresholds for warning an error. We want a rule to collect the performance metrics. We want a view to show those in the folder. That's all there. The fragment uses cookdown so that the data source and the probe actions are shared between the rule and monitor so that they don't produce conflicting results and don't have more work being done than needs to be done. And the UI and the thresholds are all going to be overridable parameters. So if we come back here and look at this, this is the script for that fragment. The biggest difference here is we only have one parameter, which is the URI. We have our manual testing section here. So I have some successful cases here, like going to www.google, but I've got Gyogle and successful Bing one and unknown host just to test the different cases here. We'll just work with the Google case right now. The name and the event ID we've seen are welcome event log, we create our property bag, we clear any errors, and then the guts of this is all on the screen now. What we're going to do is we're going to use invoke web request. We're going to use the URI that was passed in. Use basic parsing, just does less work. And if there's an error, we want it just to silently continue. If it fails bad, it'll throw an exception, which will be caught here with the catch. But if it does work, our response, we have a status code, a description, and the length seemed like a useful thing. I assign them to variables. If there was an exception, I'm just getting a copy of that exception. I check to see if there was a response. If the exception came back, but we still have a response, we're going to get our status code from the status code itself and our description from the status description from the response. Typically, we don't. If it throws an exception, we don't have a response. I'm going to hard code status code 404, which is not found, because that's sort of a best guess. But for the description, I'll fill in that message from the exception. And since we didn't have any results, I'm going to return -1 as the raw content length. All of this is wrapped by measure command. And all that does is execute that block of code here, this block of code, and it measures the time before and after and returns the difference. If we're debugging, we're going to write out to the console, the URI, status code, description, etc. We're going to log the result here based on status description. And then we are going to fill in a property bag with the URI, status code, description, and the elapsed time in milliseconds and seconds, because people using this some may want to do it in milliseconds, some may want to do it in seconds. We've got both available. Adding 1 or 2 additional things to a property bag really doesn't hurt. If we're debugging, we use the MOM API return. If we're not debugging, we use the standard return. And then we have our log result here. So if we run this thing, scroll up just enough so we can see it. Here's our results. And if we run that here, there's our results and our data. And if we look at our data, and I've already done this, again, it's a property bag. We have our URI, our status code, our description. The variant types are different here. This variant type is an integer for type 3, and type 5 is like a double representative floating point. So 262.49 milliseconds or 0.262 seconds is returned. So that's our script. Let's take a quick look at it in the fragment here. So our fragment has a bunch of parameters that will be filled in, be a company name, a website name, and that's where you use something reasonable like Google versus the URI. And our threshold, what's our warning threshold and our error threshold. We have a data source module type that takes in the URI and a debug parameter. They're overridable. It has a scheduler, so it runs every n seconds, and it invokes the probe action data source, passing in the URI and debug flags. So it runs the scheduler, and when that returns, it runs the probe. And it outputs a property bag, because the probe action returned a property bag in this case. The probe action has similar parameters coming in, URI and debug, again, overridable. It has basically one member module, which is this probe action, which is a PowerShell probe action. We give it the script. And when we scroll down far enough, here's how the parameters are passed in. So that URI variable is passed in from the URI that was passed in, same with debug. We're just going to execute the probe, and we're going to return a property bag here. So the unit monitor type that's used by the unit monitor, oh, by the way, if you haven't seen these before, anything with 2 hashes surrounding it, that will be replaced when we import the fragment with the proper value. We have 3 health states here. We have our parameters coming in, which is, for instance, the URI and the warning and error thresholds. They're overridable. We have the data source that we were just looking at. We have a probe action here. The data source is used for normal detection. That's the periodic detection. The probe is used for on-demand detection. That's where you're in the Health Explorer and you say recalculate the health of this monitor. That's when it uses the probe directly. And we have 3 condition detections here. So the first one is the status code equals 200 and milliseconds is less than or equal to the warning threshold. And so if those 2 conditions are true, then everything's healthy. The second condition is our warning case, where status code is still equal to 200 and milliseconds is greater than the threshold, the warning threshold, and milliseconds is also less than or equal to the error threshold. So we're healthy, but we're more than the warning, but we're less than the error threshold. That's when we're going to be in our warning state. And finally, our or error expression is the status code does not equal to 200 or milliseconds is greater than the error threshold. In that case, we want to raise an alert. I'm going to skip a bit of stuff here. So here's our rule. The data source is that data source we were just talking about. We pass in the URI. Condition detection just maps the property bag into performance information that can be collected in the database, not the data warehouse in this case. Our monitor, similar stuff, it uses that unit monitor type that we were just looking at. These alert parameters are filled into that alert message we were looking at. Here's our health states that correlates those conditions. The under warning is success, the over warning is warning, and the over error is error. That's just how it ties them together. And then our configuration, we're going to pass in the URI, debug is false, and we're going to pass in our warning and error threshold. And again, those are overridable. We have a presentation here. That's a view, and I have hidden all the gory details, but basically this view is going to show the results of that rule. That's what the MP element name does. And we have a folder and folder items, that sort of stuff. Now we know it can take a long time for this to get sent to SCOM and populated and that sort of stuff. So we're going to look at the results here. So here's our view under the folder. I've only chosen 3 computers. This is running on way too many computers, but here's our results. Sometimes less than 200, typically around 250 to 300, but occasionally this one's as high as 600. I have changed I've applied overrides to the threshold values here so that we should have some active alerts. So here's an alert that was generated just 1 minute ago. There's that message, querying, and here's our URI has been substituted in. There's our status code, and I tell people that it should be 200. And there's our time, 250. I don't have the threshold value here. That's a little harder to find because it's an override. We can also look under View Additional Knowledge at the alert context. This alert URI, status code, description, milliseconds, and seconds, that's the property bag. Those are the same contents of the property bag that we were looking at when we looked at them here. Here, it's just presented differently. So that's one way to see your property bag, but it's not as easy to find if you don't have an alert. Okay. And the other thing we have is that the alerts are only generated for critical alerts. Let's just see if we've got anything. So we have a few that are in a warning state, a few that are in critical, and we haven't got any right now that are completely healthy because they're all returning times that's just a bit higher than the warning. So that is that. And how's my time doing? I think I'm pretty much out of time. So let's carry on. We'll come back here. That was our demo. As I mentioned, I've got a bunch of resources here. This is Brian Wren's video modules on authoring. Highly recommended. Kevin Holman, let's go back here for a second. Kevin Holman, if you're not following Kevin, you really should. All sorts of good stuff, including he's got a library of fragments. Silect has a library of fragments, which also we include Kevin's stuff with his permission. Um, also worth looking at. We've got a lot of videos on YouTube that are worth looking at. Here's the official list of SCOM management packs that's published by Microsoft. And this is the discussion forum for Operations Manager, where there's lots of requests and suggestions, that sort of stuff. How to analyze a property bag, that's that same article again. An article by Kevin Holman on how to use PowerShell scripting here. The MOM script API, that was the one I mentioned earlier. And then Microsoft has published a management pack authoring guide. That should be no surprise, of course. But there's several articles here that are specifically monitoring scripts and discovery, which talks about discovery scripts and rules, that sort of stuff. And at that point, I've sort of run out of things to talk about. So I don't know. I'm not. Oh, there's comments. Thank you, Michael Ford. Let me see if we've got some answers here. I'll be glad to go through all of these. I guess Bob liked my marathon comment. Okay. Let's see questions. Yeah, so we've got questions. PowerShell version 5 versus V7. So Will Jackson III asked if PowerShell versions matter. I'm sure it does. So if you do your testing on the earliest version of PowerShell that you expect to find on any agent machine, I think that is what you need to do to guarantee it. But honestly, these days, I think most supported versions, or if not all supported versions of Windows, are at a sufficient level that you really shouldn't have much trouble there. I wouldn't go assuming that you can use the new stuff in PowerShell.net or whatever they're calling it. There's a lot of really good stuff there, but that's not going to be available on most machines.